DC power sources. That's next. See how much we remember about this. This is about the time I came back from my trip in New Jersey. Power sources. There's different configurations that you're required to identify. What's the learning objective say, Mr. Elliott, like the first one?
Without data references, giving us array of multiple DC power sources, start the statement that identifies the configuration of sources as total draw.
Okay. Configurations. You have to be able to identify when giving this example, identify what kind of configuration this is. This one. That's what the first one's talking about. What's the next ELO, Mr. Shield?
Without data references, giving a schematic diagram of DC power sources and specified configuration. It's like the statement that identifies total applied voltage in the circuit that runs the problem.
Okay, this is the part where you started learning about things like voltage is what in series? Additive. Current is common in series. Here, parallel, we learned that voltage is common and current is additive. Those types of things. The rules started becoming evident in this lesson here. Mr. Fry, what's next?
Given us a specified DC power source circuit, lab volt workstation, test measurement, and diagnostic equipment, record the specified circuit's parameters in accordance with draw.
You're done. That's performance-based, isn't it? Didn't we just do that? So the rest of them are performance-based, or was that the last one?
That was awesome.
Okay. So the ones, the ELOs that talk about giving test measure diagnostic equipment, do this, do that, or take readings, that's performance stuff. And we just did that this morning. So we're mainly focused on written exam type ELOs. So basically, what do we have to do for DC power sources? Identify configurations and be able to determine total potential current. That's about it, huh? Not that tough. So this first configuration, I have several, what are these called? Cells connected. It looks like it's series. How do we know? Because they're tied, basically end to end. This would be a series what type? Series 18. And how do we know this? Yeah. Look, negative. Because we should know by now that in a cell or a battery, the long line is what polarity? Yeah, and the short line is negative. And furthermore, if we start from the left, positive, negative, positive, negative, positive, negative, okay. So that must be 80 because they will all add together to give me a certain total potential. So if I were to assign various values, we should be able to determine what the total potential is. That being what? 1, 2, 3, and 5 volts respectively. Because what's additive in series?
Voltage.
Yeah, 11 volts. That's the total potential. Couldn't I call that a battery? I could. 2 or more cells make a battery. What about current? Come down here and I'll give each one a rating. I'm saying 2 amps, 3 amps, 1 amps, 3 amps. How do I know how much current that can actually be produced from this configuration?
Smallest value.
Yeah, it's the smallest one. You got to pick the smallest one, so it'd be 11 volts, 1 amp, like that. Ringing a bell?
Yes, sir.
Okay. What about the one below this? That must be series what? Opposing. You have to be able to identify these things. Not opposing. Set this thing up. All right, Dan. Notice the difference in the configuration. Yes, no, maybe.
Yes, sir.
So we start from the far left. Positive, negative. Oh, crap, it's negative. We start from the far right, I don't believe it. Positive, oh, crap. So it must be opposing. What did you learn, or you may have already known this, most of you probably already knew this, about charges as far as like and unlike charges? Unlike charges do what? And like. And that's a concept we can use to apply to this. So I can go ahead and assign values once again. Well, I've got 4, 6, 3, 8, and 2. I need to know what the total potential is for that configuration. Some of you are good enough to sit there and eyeball it and be able to tell me.
7 volts.
Down here is 7 volts. Those of you that are like, huh? What were you told to do? Group them, right?
Yes, sir.
So we can start here. So let's look for another cell that looks like that. This one? This one?
Yes.
All right. This one?
Yes, sir.
Okay. This one? So we've got 4, 3, and 8. And what does that come out to? 15. We'll write that over here. The next group is whatever's left. We got 6 and 2. You have to add them because these are like, add them together, 6 and 2 is 8, correct? And how do we get the total potential? Opposing, we have to take the difference. What are 2 groups? And it's 7. Good job. The current rule is still the same. Pick the smallest one. Series aiding and opposing. Any questions?